Alright, Edithson Abelard, and I'm back again for the next video. And what we want to do in this one is we want to work on our particle system. Now, the whole point is we need to be able to control the particle system. So let's start off by going back into our script for our hot water. We're going to create another public variable. We're going to call this sink water. And this is going to be of a type particle system. It's alright if it doesn't recognize it. And what we want to do is sorry, not particle system. What we want to do is make this a game object. So sink water will be it'll definitely still be here, but it's going to be private. Now let's create a public one. Because what's going to happen is when we create our particles is going to be emitted from a separate object. So that's going to be a game object that we're then going to get component. And that component is going to be a particle system. So we're just going to call this sink water obj. Nothing to do with an actual mesh. And this is going to be of a type game object. And same thing as we did before, we want to set this, or we want to check to see if it's set on awake. But in our case, we're going to skip that step. So if we come back in here, we look at our script, we have this sink water. So what we're going to do now is we're going to just create a particle system. So let's go ahead and we don't need to create an empty game object. We just need to create a particle system. We'll drop it in here. We're going to name it sink water. Actually, it'll be easier to type that way. So first thing we'll notice is we're going up to the sky. So let's get rid of this rotation. And okay, we're looking a little better, but we need to be going down. All right, so we're getting there. We're getting there. Now you'll notice something. We can make these modifications in here. Oh, we already skipped that. We can make the modifications in here, but as you saw previously, there's actually a particle window. And if you're going to do things, I would highly recommend you control the particles within this screen. And the reason for that is if we scroll down to something like velocity over or size over time, you see you can check this on and you have this. If you're looking in this screen and we come down here, you can make modifications, right? But this is kind of useless. But when you come into here, then you have the ability to actually change the curve. So you can see that, you know, how it affects. Now it looks like snow a little bit, but we'll definitely make this thing look like running water in no time. All right, cool. So now what we need to do is let's start off with some little things. How long does it last? 5 seconds is cool. Max particles, I'm going to make it 2000 because we're going to have to spit out quite a few particles. Start speed, we're going to bring that down to 1. And I'm only bringing the start speed down to 1 because we need to actually see when we scale this thing down, we need to see what the scale is going to do to the particles in relation to the speed. So we go down to shape, and right now it's set to cone. So now we can actually visually see our cone. The angle is fine. It's the radius we need to bring down. And as you can see, you know, now we can see how fast it comes out, and then we can control the speed once we get the size right. Because now it's just spit firing. All right, cool. So definitely we already know this size is absolutely horrendous. So let's go up and let's change the size of the particle. So right now it's set to 1. Let's do 0.1. Okay, who are we lying? 0.1 is probably, we'll keep it at 0.1 for now because we want you to actually see the particles as well. So we probably still need to take this thing down in size. So let's go back and let's change the radius to maybe a 0.2. And let's take the angle and let's just bring this down just slightly. Cool. All right, so now it's coming out very sporadically. So what we want to do is go into emission, and right now we're only emitting 10. Now it looks really cool because you can kind of go down to 0, but what we really need is we need a lot more particles to come down to make this thing look like it's flowing. So sorry for that. So that is just an enormous amount of particles, but it's okay because oh, you saw that? That's emitting way too many. So 250, we get this like off pattern, which is great. But what we really want to do now is just really control the size. So let's look at maybe size over lifetime. Because technically, when this thing is coming out, it's actually not coming out in the fashion we have it in right now. So let's click on this. It normally when water comes out, it's going to have to come out smaller and get larger. So what we're going to do is start it out nice and small, and then we'll make it larger over its lifetime. Now, we don't actually, in our current state, we have it set to live for quite some time. So if we change the lifetime, this will automatically change our curve. So start over lifetime. As you can see, it drastically changed it. Set this to 10 seconds. So, all right. So you just have to keep playing with it until you find something that works for you. All right. Now our cone angle currently is just a little too steep for us. So let's bring that angle down. And I want some, somewhat of an angle, because what we don't want to happen is we don't want these particles to just come straight down, especially if you want to make this, realistic or just even more enjoyable. You want to maybe do something like, wait for it. We jump into collision and let's set this to world. And what we'll be able to do is, let me just make sure I have something on here. Mesh. I don't have anything. So what we can do to the sync is we can add ourselves a component, a mesh collider, and let's go back to our particle. And now you can see it's actually bouncing right off of it, which is awesome. So let's continue and maybe dampen this up. We have to play with the collision just a little bit, because we don't really want. In this video, I'm not going to go into detail, just what each one of these things do, but you can definitely look out for that to come, sometime in the future. Get rid of the damping just a little bit. Lifetime loss. So you can see as I'm going down, its life is basically deteriorating in front of us. Getting its kill. And what I really want to do and not forget is this gravity multiplier. So what's going on here? Realistically speaking, we always have gravity affecting us at every level. This is probably the worst reference possible, but if you remember Dragon Ball Z, in the old episodes when Goku is training basically, and he needs more strength, what he does is he has this gravity multiplier, which in turn makes everything heavier. And so when he multiplied gravity, I forgot about how much, and he just started walking around. It was difficult. After a while, he got stronger. But then when he removed gravity, he was even faster at regular gravity. So what we're doing here is we're going to multiply gravity. And what this does is as you can see, we get, well, you're not seeing it now, but what's happening is now it's bouncing. Now it has a better bounce to it. So instead of going right up in the air when we had zero gravity, now we have gravity, which right now should be set to 9.8, which is our normal gravity. So we can set it to half if we want to, but let's go back down to collision now and let's make some more modifications to it. All right, so dampen is what's slowing down that and taking away that force, but we want this thing to keep going. So There you go. Maybe add a little more bounce to it. Now we're talking. This is like a crazy flow. And this is where if we actually go back and we change our radius, our cone angle, sorry. See, now it starts to make a huge difference in how it comes down. Because if our angle is sharp, you know, then you get everything going to one point, where when it's wider, it just opens it up just for a little more depth in the collision. That's great. Some of it's probably going through because of speed. So these are the type of things that we have to worry about when we're working with particles. But, you know, thank goodness Unity doesn't allow us, Unity doesn't require us to keep compiling, so we can keep playing with this until we find it and make it exactly the way we want to. So what can we change next? This is still open. Let's change our size over lifetime, because these are getting way too big. Starting out too big, and they're staying way too big. All right, so what you're seeing now is a lot of gaps in the actual particle. So we might be able to fix that just by adding more particles. So double that. Maybe even take that up in size. Bring down the speed just a little bit. Actually, let's bring down the lifetime. There you go. That'll help. So we don't have particles going down so low. All right, so we can let this pass for now. We can definitely keep tweaking, you know, to our heart's content. But what I really want to show you is just, we want these particles on, and we want them to be bouncing within our sink. So with all this set, we have our sink water. Now what we want to do is go to our game object. Oh, excuse me, the sink water is our game object, but we want to go to this this component and go down to hot water. And what we want to do is just lock this real quick and grab our sink water. We're going to drop our sink water onto our component. So basically what we did now is just reference the sink water particle system, which is actually just a game object with a particle on there. And now we want to access it. So to start off with, we want this to not play. So let's go into our particle system and make sure that this play on awake is set to false. And we're going to do what we basically were doing before. And we're going to this time control our sink water based off of our click. So let's go back into here. And now that we have a game object here, within this awake, what we're going to do is set the sink water variable. So sink water, which needs to be a particle system, is going to be equal to the sink water object dot get component. And what we're looking for is a particle system. Okay. And so now what this should give us is a particle system and this is just for good measure, as a particle system. So now we know the sink is on. So we're just going to literally say play. Sink water play and sink water stop. Okay, great. So we're just going to hit play. Oh, let's see what we have. Sink water. Sink water, hot water. See, that's why sometimes you really should type in your own work. That's cool though. So let's come back in here, see what else is going on. Once again, same thing as before. We're in the code, I just copied the wrong thing. So that method actually does not exist, which Unity is right. So now let's hit play. And we come in here, we see our sink, and we click on it. Whoa, click on it, it's gone. So that's really all we wanted to do, and that's really all we needed to do. And now you have a nice little system where, we have our water coming on. Now, what can we do to enhance this? Well, let's let this thing go. Well, first and foremost, do we really need to control the sink water in here? Nah, we don't really need to. Because what we want to eventually do is we want to basically play both the hot water and the cold water. So we can copy this script and just multiply it and just put it on the cold water and just change a few variables and we're back in business. But what's going to now happen is that this system is going to be controlled by each individual, and what we don't want is for each individual to control the system. So instead of accessing the actual particle itself, we can actually split this up one more time. And let's actually create a script. Go into our project. Like I said, try to be as neat as possible with this, and let's create a new script. Actually, let's do something even funner. Let's actually, on this particle object, let's come in here and create a new script. We're going to name it, we're going to call it sink control, because that's what it is a sink control. Alright, so we'll let this thing start. So now what we want to do is we want to expose functions to our player. And by doing so, we get to now control the sink from our end instead of having, instead of having the sink control being controlled by these individually. So let's go in and let's add another. So instead of having our sink water game object, what I want to do now is go back and add the sink water controller that we just created. So we're going to do a public variable sink water control, and we're going to set it to sink control, and that's the name over here. And so now what we're going to do is we're going to take this sink water control and set it to still grab the sink water object, because we still need the object, because that object is controlling is what everything is attached to. So now we're going to get component, and we're going to get sink control, and we're just explicitly setting it once again to that type. So sink water control. So now instead of running this play in here, I want to run the play from within here. So if we just dot play and then dot stop, and what we'll be able to do now is now run, if we need to do any logic, we can do it on the actual controller instead of on the on either one of these objects, because we know that we're going to basically have the hot and cold water. So this just allows us to now control it from within here. So we have the play function, and we're going to have to duplicate it and create a stop function. So same thing as before. We're just going to set some. We're just going to do some house cleaning. Set up some variables. Is running is a boolean. What else do we have here? So it's actually set to false to begin with. I know Unity is going to bug us about that boolean, so I'll leave that for now. Private variable count, and that is going to be a float, and we'll set that to 0.0. And we're going to now grab our particle system and set private variable called water. And our water is going to be a particle system. So it's particle system. It's all right. Unity doesn't recognize much. Anyways, particle system. And we want to have another function. We want to overwrite the awake function. And what we want to do now is we want to set water equal to our current particle system. And if you remember, if I come back in here, we were just getting the component particle system. Now, in this case, we're not going to have to grab the particle system. We're just going to set it to particle system. And water.play. And water.stop. So now let's check if Unity found anything cool. Can't convert type to as part. It's all right. There you go. So that's all. That's just data typing. This is double check our code. So now we have the animation playing, but now we have our sync controller being the one that does the play and the stop. So let's jump into this and see how it works. We have a problem. What am I doing? How can you forget to get the components? All right. So now that we've grabbed the component, let's try this again. There you go. Well, obviously something's not liking me, but the water did turn on, so that's that's the first sign of things are working. Well, obviously can't do that twice. All right. So now the reason why we separated them. Now that we're no longer controlling the hot and cold from within here, what we actually did is we opened up ourselves to now being able to, in this case, duplicate the code and throw it onto the cold. And then our count function here is actually going to check to see, how many are actually being played. In this case, we know our maximum is 2. So we're just going to create a separate function, and we're going to call it counter, and all that's going to be responsible for is controlling how many we have here. And what this is basically for when we have the hot water and the cold water, we want to make sure that we have the ability to show both. Both are actually affecting the faucet, and we want to see it get stronger. So what we're going to do in the next video is we're going to finish this section and show you just how easy it is to continue this method and create a system that will work on both. Here's an Abelard. I'm out.